Lesson 15. So we are going to get to Cares just now. Cares is just Mrs. van Skalkwyk's own way of saying trig equations. But you're going to know it as Cares because that's how I speak about it. Nobody else will know what you're talking about. We'll see when we get there why I call it this. Trig equations, but we're going to get there in 5 minutes. The homework, the previous homework, was still about reduction formulas. It wasn't even left-hand side, right-hand side. Okay, it's just when you see 180 plus, you must know it's a poof sum. That's it. That's what I'm looking for. So 180 plus goes poof. And then you must not forget that you're in the third quadrant. You've got to check tan in the third quadrant is positive. If you want to put the positive there, Dan says it's fine. Rather than making a mistake, rather put the plus. 360 plus, something's wrong there. The 3 that you know is 180 minus 180 plus 360 minus. Poof, 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 right? But what about 360 plus? Poof, 360 plus? Poof. You just throw away 360. It's more than 360. It's more than 360. Do you see it? You see it now? 360 plus. So just throw away the 360. Did you miss that?
Yes.
Do you understand it now? 360 plus isn't a new reduction formula. It's just saying it's more than 360. So what do we do with more than 360? Throw away the 360. What about the sign? Nothing. We just throw it away, right? So that's a mark and a mark in a text. This one goes poof again. And sin in the third quadrant is negative, and then only do you get your mark. Not for sin. Negative sin, then you get the mark. Aha. Poof puff. 90 plus. All I'm allowed to ask you is 90 plus and 90 minus. Then you know it's poof puff and you go poof. So it's just the theatre, the 90 plus goes away. But then puff becomes sin. But you've got to check. Is it positive or is it negative? Is it about the cos or about the sin? You used to be in the second quadrant with cos, which is negative. Now you're in the first quadrant. This reduction formula has brought you back to acute angles. But the original one was negative. And only if it's exactly like that you get the mark. Plus, don't make it a times now, plus. Now cos square, 360 minus, well 360 minus goes poof again, right? And then cos is in any case in the fourth quadrant is positive, but that's beside the point. The moment that there is a square, you don't even worry about the sign because square is going to in any case be a positive. So this positive will be times with a positive and stay a positive, all because it's a square. Right, so that could be 5 marks for one step. Then, cancel out the cos. Why not? Pluses and minuses. If they're all times and divide, then it's fine. But they're not. Okay, but what else then? Tan? Make it sin over cos. Would it help? Sin over cos times cos? Yes, it will help. So there's a mark for knowing that tan is sin over cos. How does it help me? Because that cos is actually over.
Wow.
Aha. That I can do. But man, the plus underneath, no problem. No problem. It's not involved here. Oh, what here? Nothing can cancel. But what is minus sin times minus sin? Positive sin split. And I do nothing there. And then that identity equals 1, which is worth a mark. So please give me something to give you the mark for. So show me that you know that it's 1. Some people just do that and write there that it's 1. They are quite lenient on that case there. But then in the event, at the end, the answer is just going to be sin over 1. If you want to write over 1, it's fine. As long as I can see that you know that that was 1. So maybe highlight that, highlight this, so everybody can see. that you know that it's 1. Okay, that would be worth another mark for knowing that it's 1 and for your eventual answer. So these questions are about 7, 6, 7, max 8, but more often just 7. Alright, so this one again, is it left hand side, right hand side? Now, what would it say? Prove that this equals, I could have made this left hand side, right hand side. I could have said, prove that that is equal to sin. Then it's nice, because actually you've got the answer, you've got the memo. That's what I like about the left hand side, right hand side. If I didn't crook it right and I do get to the answer that they wanted, I know I should be right. Okay, for this one, no left hand side, right hand side. So let's go through the motions. What is there to do with sin 70? Say again. Cos 20, yes, but why would you do that now?
Yeah.
If you've done it already for homework, you know why. Because cos 200, you're going to change into 180 plus 20. So what's going to pop out of here?
180.
Cos 20. Okay? How's that going to help me if this is sin 70? Okay? So if this one was sin 70, leave it sin 70 for now, and then eventually, okay, I'm deciding to make it the same for cos 20, and then it can be cos square. But just as well, I haven't looked at this yet, but just as well I can change it into sin square 70. Are you with me, guys? Because now I'm looking on the right hand side and I see a 70. But I also see a negative angle. What's the rule for negative angles?
Make it a positive.
Make that negative angle a positive angle, then the function or the ratio becomes negative, except for cos. But except for that, it's except for cos. It's a square anyway, so that will be positive anyway. But what about the minus in the front? It will stay where it was. But there's no changing the sign over here because it's cos, first of all. It doesn't change, and because it's square. And now since I'm seeing the square and the 70, I think maybe we should go for, is it going to help me to change it into? If it's minus, did I write it down correctly? I think they didn't want that. I would have changed the sum if I was marking this, the memo, if I was moderating it. Because you can't do anything else. That's the answer. That's the answer. And if you had left it as cos square minus cos square of 70, that's also fine. This is actually something that you would be able to do in Trig. I think what they wanted to do, and they think that they made a typing error, if they had made that a plus, if it was plus, then it was equal to, but there's nothing else you can do here. And also, you didn't have to make them both 20. You could have left the one 20 and the other one 70 because there's no use of doing it. Are you with me? So I would have made, as a moderator, I would have made that a plus. Plus, plus, plus. And then your answer would have been equal to 1. What about sin square 70 minus cos square 70? Well, that's all the options that you have. Either. And again, I want to say they don't have to be the same angle because there's no reason for it. If they were plus, yes, then you would want to make them the same. Okay, now you have solved angles before in your life. You have. With your calculator, how do you solve an angle with your calculator? What do you press? Shifts in. But first of all, this is not so new for you. First of all, you've got to get that sin alone, right? Yes. So it's going to become 2 sin x equal to negative 1. So some of you don't have order of operations down. Some of you want to divide by 2 before you subtract the 1. That's terrible. And then still to get to sin x equal to negative half. Now that you did last year, but you didn't do it with the negatives really because you weren't into class that much. So now the routine is, you like routines, right? This is routine. I'm saying that there are 4 types, and the first type is where you've got sin, cos, or tan, any one of the trig ratios equal to a ratio. Is it sin, cos, or tan equal to a ratio? Yeah, that is 1 to 2. 0,3 is actually 3 to 10. It's a ratio. Something, comma, something is a ratio. So I need it to be a ratio. 1 mark to get there. Then you've got to go work out your your reference angle, ma'am, is only going to write reference angle like that. You're going to know it from now on. All right. How do you work out the reference angle? Now you need to know, we're busy with sin. I need to sketch this for you and show you that sin, as we know it, right, carries on and on and on and on, and carries on and on and on and on. Are you all with me? So if I want to know where sin graph is equal to negative, do I have to do the sketches? Please no, I'm just explaining to you where I get this from. So if sin is equal to negative a half, and you should actually know that a half is for 30. Half would be 30, but ma'am, I'm not asking for a half, I'm asking for negative a half. But negative a half will be negative 30. And what will that one there be? What's this? 180. What will this be? 180 plus 30. What will this one be, do you think?
Plus 30.
360 minus 30. And the next? And the next, and the next, and the next, and the next. How many times is it going to be equal to negative a half? As far as I've drawn it, but I can't draw it until infinity, up to infinity. So how many times is your sin graph going to be equal to negative a half? A lot. Infinitely many. But there's got to be a technique. So the technique is to always get your reference angle, a positive angle in the first quadrant. So you ignore the negative, guys. This is crucial. So when you go for your calculator, you don't put in the negative for your reference angle. That's the note that you must make for yourself. So you're only going to put in, what are you going to put in? Shift sin of positive a half. But then what will your answer be? Positive 30. But you're going to use that 30 to get to all the other quadrants. Like I showed you here now. 180 minus, 180 plus, 360 minus, as you know it. Are you with me? So first of all, the reference angle is, I've just told you, it is 30. How do you get it? With your calculator, but you're actually supposed to know it, because it's a special angle. That's sin of 30 would be a half. Now that I know it's 30, you've got maybe 1 out of 5 marks. Because now there's the heap of other stuff. I need to tell them that I know that it's infinitely many of them. So this is the method. I must now decide in which quadrants I'm working. Let's do it in red. Where is sin negative? Third and fourth quadrants. Still says cost. Where is sin negative? If it was positive, it would have been first and second, and so on with all the others. Then what you do is you write down quadrant number 3 and quadrant number 4 are going to be my answers, right? In these quadrants, you're going to write down, for the first time, I'm going to write it very elaborately. You're going to write down the name of the angle equal to, and in quadrant number 3, what's the magic word? Quadrant 3. 180 plus. Right? And in quadrant number 4, you're also still going to have the name of the angle. 360 minus, and if it's quadrant 2, and in quadrant 1, just the angle that you've got. Quadrant 1, that would have been 30. No, 180 minus, 180 plus, 360 minus. Quadrant 1, it is just the acute angle. Okay, you're going to have to do a few of them, do you agree? So now the name of my angle here was? The name of my angle was x. Do you know that sometimes we have 2x? Or we have x plus 30 degrees? Then that's the name of the angle that comes here. So it can now be x, or x plus 30 or 2x or whatever, so you're still going to have to do something to get x alone. But this was just x. So it's 180 plus what, you think? Your reference angle, your 30. And that's not all, because now I've got 210, which I know it was supposed to be here, right? Plus 30 will be 2. 10. I've got one answer out of a million. Infinitely many. How will I get to this one? This will be 360 minus. But then I've got 2. 360 minus 30, which would give me 330, right? How many answers have I got? 2, man, that's wrong. You just said to me that there's infinitely many. So here's where the keys part comes in. Now I say, that one there, and this one here, please focus on the board, and this one here, are how far apart? 360, and 360, and 360, and up to there is again 360. You agree with me? So I'm saying to get all of those dots, dot, 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 I just have to say, well, take it and add 1 times 360. Add 2 times 360. Add 3 times 360. Add a certain amount, which is going to be k, you know that we love k, times 360. So your answer would be not 210, but 210 plus. Now the k I've got to explain. And that's where the keys comes in. I've got to tell them, listen here, that k that I just popped in there, because ma'am taught me that k must be a, what does that mean?
Yes, right.
Element of the integers. What are the integers? 1, 2, 3, 4, 5, and -1, -2, -3. So this means that k there can be either 1. So if you add 1 360, you get to the first dot. If you add 2 times 360, you'll get to the second, and 3 times to the third. And -1, you'll get from there to there. And -2, and -3, do you see how cleverly they put it together? So any amount of 360s to the negative side, to the positive side, will include all of those dots. But now I don't have all the other ones. Let's make them little crosses. From that cross, which is 330, I will have to add 360 again, and 360 again, and to that side there will be the partner, and go on and go on and go on. So guess what I'm writing here? Plus k times 360. So from 330 I will add once, twice, 3 times, and -1, -2, -3 times. Clever way of writing. Add as many 360s as you can and subtract as many 360s as you can up to infinity. And it's crucial that you write k's, because you didn't know the first time I wrote k there what it was.
Yeah.
So every time you put the k there, you've got to explain to the marker it must be an integer. So all the negative numbers up to infinity, all the positive numbers up to infinity. And there's your first k's sum. Now I'm talking about a general solution there. That would be a general solution. We need to do at least one more. Pay attention. If we look at another one. Example 2. So you're getting this whole idea about the sketch. You're not going to sketch it, but so you can see. You're finding the first your reference angle. Was that even one of the answers? No, it's just a way to get the 30 to know it's 180 minus and 180 plus, and 360 minus to get to the correct quadrants, because you want it to be as negative, so it's got to be in the third and the fourth quadrant. You see it's beautifully coming together. Okay, to me. Maybe not to you yet. Now let's look at tan. So it can be either sin or cos or tan. I'm not going to do a cos one as well. Sin or cos or tan equal to. Can I divide the whole thing by 2? No. You never could last year as well. This is the angle's name. That's where you're going to put it. When you find it, you're going to name the angle 2 theta. This one will say solve for theta. So first of all, what's my first step? Find the
Reference angle.
reference angle. How? What do you put in your calculator? Positive. Yes. Shift tan of positive 1, 2. Positive 1, 2. So you're going to get the reference angle as an acute angle. Is that an answer? No, it's just a tool to get to your correct answer. First thing, so that will be how much?
50,
15.
50,190.
50.
50. Yes.
50, comma
19.
19. Please always do 2 decimals because the matrics are always 2 decimals, so I stick to 2 decimals unless the question asks somewhere else. Is it 19 correctly rounded off? Okay. Then, after getting the reference angle, I've got to find this for myself. Is this worth a mark? No. Nope. It's for you to sort out that it's quadrant 3 and quadrant 4. Now, where is tan?
Quadrant 2 and 3.
Negative. Quadrant 2 and quadrant
3. 4, sorry.
Get your cast right, girls and boys. Tan is negative. Tan was positive in the first and the third. So where do we go? Where do we go? What do we write next? Quadrant 2 and quadrant 4. Are you with me? Then we write down the name of the angle, which is 2 theta. And now I know what's going to happen once I've got that 2 theta. I'm going to divide the whole thing by 2. Then I can, because now I'm going to be with angles. But in quadrant 2, you immediately write 180 minus. And 360 minus. And quadrant 3, 180 plus. You're never going to get away from those basic reduction formulas. All right. Minus what? The 50, 19. And the 50, 19. And what must be added over here?
Plus k times 360.
K times 360. But wait a second. 10. It's got some kinky thing. No. Guys, if forever you want to do 10 this way, it's fine. But I'm going to teach you a shortcut. And you want shortcuts because the second paper is always a lot of work and you need more time. So you don't want to do this. I want to show you something. Tan, out of its nature, has a period of
180.
180. You agree?
Yes.
Because there's a whole tan graph. From minus 90 to plus 90, which makes it a whole tan graph in 180. That's what a period is. And from 90 to 270, a whole period. Are you with me? Oh, horrible sketch. But anyway. I'm trying to find out this angle, and the name of the angle is 2 theta. What would have happened to this graph? The angle the girls should have been divided by 2. Now, we're not thinking that. I'm just saying, if it was a normal tan graph, and we wanted negative 1, 2, we would have had answers. Oh, where am I now? Answer there. Okay? Answer there. And next one there. And next one there. How far are they apart?
180.
Exactly 180. I don't need to put it into 2 groups. One with a dot, dot, dot. One with a cross, 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 like I did with the sim graph just now. Because they weren't all the time the same apart. I had to go from dot to dot to dot, 360. Cross to cross to cross, 360. Are you with me where I am in the sim? But this one, I don't have to. I'm saying you don't have to do the second one. As long, and I want you to do it this way. Show yourself there in the book. You can scratch this out instead of saying k times 360 there and k times 360 here. But then it's wrong. If I scratch this out, then that has got to be k times
180.
Excellent.
Oh.
Because from the one that you've got to the next one is always going to be 180, 180, 180. 1 times 180, remember now what k stands for? K stands for? And you've got to write k's there. Sometimes they don't give a mark for k's. Very often we don't. But if it's not there, I must deduct one. Okay, important. There must be k's there. Explain to me, where did you find this? Because if tomorrow you feel like writing p there and your k's becomes k's, I'll say, okay, no problem, whatever. Are you with me?
Yes.
Because you're explaining to me what that must be. So, but now I need you to understand why only with tan does this happen. Because cos does the same as what sin did. It's also going to be where this one is equal, will be 360 apart. But where that one is equal, also be 360 apart. You see the crosses and the dots again. You're going to have to write both quadrants. Both with k times 360. 60. Now I want to again say, if you're confused with it, and you always want to write 1 and 4, and want to write 360 on both places, are you right? Yes. Because then you're giving me with this one section, you're giving me that one, slip one, that one, next one. And then the other part, you're doing all the rest of them in between, and that's fine. No problem. If you want to stick to one method. But you're going to save some time with 10. But you've got to understand why. This is why it takes long to explain it to you the first time, that you can understand why. This is always just exactly 180 apart. You can do both of those. It would be perfectly fine. But it saves you some time. Am I finished with my answer? Almost.
No.
2 theta is equal to, please give me an answer here, 180 minus a, 120.
9,81.
And please remember, you can't at the end of the sum put the K180, because this is now going to be divided by 2. And the K182 divided by 2. What's the answer, please? 60?
64,990.
Okay. Plus K times? Aha! Man, what's going on here now? Remember the graph? All the girls were divided by 2. So actually this is your period. If all the girls are divided by 2, the period should be 90. That's why you put the K times 180 or the K times 360 from the start. So if you need to divide by something, that'll also be divided by, depending on what the period then was. But it's like a routine. Every time you do the sum, you're going to say, and now I've erased it, so -1 mark for math. You have to have the test then. Talking about a general solution. That means all the dots up to infinity from here up to negative infinity and positive infinity. How many answers are here? Infinitely many. If I don't put the K times 90 there, I've only got one answer of infinite answers. So actually you should get 1 out of 7 or whatever the question was. Okay. Practice makes perfect, guys. Okay, so you've got 2 sums for homework. That's the name of the angle. That's the name of the angle. Can I get rid of that 2? Yes. Divide by 2, divide by 2. But you cannot say minus 20, plus 20 here, and times 2, divide 2. You can only do that once you've got the angle. First step, get the reference angle. Second step, it's positive, so pos is positive. First, and 4. Do I have to do both?
No.
Yes. You only don't have to do both for 10. Because how far are those 2 apart?
180.
Exactly 180. And if it was there, exactly 180. But how far are these 2 apart? I don't know. But much more there. But from there, back again, and back again will be 360. And from there, back again, 360. You need to write both. You can't combine them. Okay? Try your best, because tomorrow we're doing Europe. Guys, please. This one, away. I did put it on, eh? Did I put on the homework?
You never switched it on.
Oops.